Venus is a beautiful, elegant planet, seemingly very calm and almost tranquil on the surface, wrapped in a soft cloud like a blanket. From an outsider's perspective, it's clear why it's named Venus, the Roman god of love. But go beneath the cloud layer, and you'll find quite the opposite. Scorching temperatures, volcanism, and a crushing atmosphere are what you'd actually find on the surface. There are few places in our solar system more deadly, and its acid-laced environment makes visiting next to impossible. So, what do we know about this beautiful, yet hellish planet? More than you might think. Join me today as we delve into what makes this planet unique in our solar system. Subscribe and like if you find the video interesting. Ready to find out everything you could want to know? Let's start by stepping back a bit to see where this planet fits into our solar system. Venus is the second planet from the Sun, and it's our closest neighbor. Its average orbital radius around the Sun is 0.72 astronomical units, or roughly 108 million kilometers. It doesn't vary much at all from this mean orbital radius, as it's the planet with the least eccentric orbit, orbiting in a nearly perfect circle. At Venus' closest approach to us, it is the closest of any other planet, being only 41 million kilometers away. Interestingly though, this is not when it's brightest in our sky, as when it's closest to us, we only see the night side, as it's between us and the Sun. It is still visible though, as the sunlight refracts through the atmosphere. It's actually brightest when it's between us and the Sun. It's a thinner crescent shape in the sky. And when this happens, it is the brightest object we see at night after the Moon. As such, Venus is commonly misreported as an unidentified flying object. US President Jimmy Carter reported having seen a UFO in 1969, which later analysis suggested was probably Venus. Countless other people have mistaken Venus for something more exotic due to its startling brightness. I recently had the pleasure of looking at Venus through a telescope, and remarkably, the crescent shape of it was very visible. With Venus orbiting between us and the Sun, it may make you wonder if Venus ever eclipses the Sun from our viewpoint on Earth. And the answer is yes, but surprisingly, very rarely. Transits happen in pairs, the pairs being 8 years apart, but every pair only happens once every 100 years or so. The last transit we had was in 2012, but if you didn't see that, I'm afraid the next one won't be until 2117. The reason for this rarity is because the orbiting plane of Venus is not exactly the same as Earth's. Also, Venus only catches up with Earth every 584 or so days. These two things combined ensure that, although a spectacular and predictable sight, it also means we'll probably only ever have Venus. We'll probably never have the chance to see it once or twice in our lifetimes. All the planets orbit anticlockwise around the Sun, and with this, Venus is no different. But unlike all the other planets, it rotates clockwise, or in other words, in a retrograde rotation. Not only that, but it has an extremely slow rotation, rotating once every 243 Earth days, slower than any other planet. This makes a sidereal day longer than a Venusian year lasting 224 Earth days. A sidereal day, which is sunrise to sunrise, is considerably shorter, at 117 Earth days. This means you'd experience just less than 2 days on Venus in 1 year. To give you some perspective as to how slowly it rotates, at the equator, the planet is only rotating at 6.5 kilometers an hour. This slow rotation makes it the second most spherical object in the solar system after the Sun. It is unclear why Venus rotates backwards, compared to the rest of the planets, but it could be due to a big impact with another object billions of years ago, or tidal locking with the Sun, or tidal effects on the Venusian atmosphere. Its mass and size are very similar to our Earth, hence why it's often referred to as our sister or twin planet. Venus is one of the 4 inner terrestrial planets, and it is a rocky planet. Its diameter is slightly smaller than Earth's at 12,100 kilometers, compared to Earth's 12,740 kilometers, and its density is 5.3 g per cm3, compared to our 5.5 g per cm3. This means the gravity on Venus is only a tenth weaker than that on Earth, surface gravity being 8.9 m per second squared. But this is where the similarities end, because on the surface of Venus, the atmospheric pressure is 92 times greater than that on Earth. That's an equivalent of 1 kilometer under Earth's oceans. The reason for this is because the density of Venus's atmosphere is 93 times greater than Earth's. Fit that amount of gas into a space slightly smaller than what we have here on Earth, and you can understand why it's so densely packed. The atmosphere consists mainly of CO2 gas, and combined with sulfur dioxide clouds, you're left with the strongest greenhouse effect in the solar system, with temperatures of 462 degrees Celsius at the surface on average. This makes the surface temperature greater than Mercury's, even though Mercury is closer to the Sun, and Venus only gets 25% of the solar radiation that Mercury does. The difference is that Mercury doesn't have an atmosphere to retain the heat, whereas Venus certainly does. This means at night time, and even at the poles, the temperature remains fairly constant. Venus really is cooking. It absorbs so much heat, but like a thermal flask, it retains it, and doesn't let much escape. With an axial tilt of only 3 degrees Celsius, it also means seasonal changes in temperature are also very minimal. Wind speeds aren't very high on Venus' surface, only being a couple of kilometers an hour, but because of the thickness of the atmosphere, it applies a strong force on the obstructions, moving small rocks and dust across the surface. On the other hand, wind speed at the cloud layer is much faster, reaching speeds of 300 kilometers per hour. These winds at the cloud top circle the planet about every 4 to 5 hours of Earth days, which makes the planet look like it's rotating a lot faster than it actually is.